welcome to my channel. Today we are going to learn how to find the top speed of a vehicle. So for finding the top speed, we need the following data. We need the coefficient of drag, we need the air density which is taken as 1.225 kilogram per meter cube in the sea level, and we need the projected frontal area of vehicle, we need the coefficient of rolling resistance, we need the weight of the vehicle, and we have to get the data about downforce of the car if we have, and we need to know the power of the vehicle, which means the power of the engine, and we need to know the speed of the engine which is in rpm, and also we need to know about the gear ratios of the transmission system and the efficiency of the transmission as well as the radius of the tire of that car. You must be familiar with the first method, which is usually used for finding the top speed with respect to the coefficient of drag and the rolling resistance. So let's have a look at how we can find that. The total power of the engine by considering the transmission efficiency will be equal to the power for recovery overcoming the air resistance, the rolling resistance, the gradient resistance as well as drawbar pull. If we are assuming the vehicle is moving in a straight road with no gradient, the value of gradient resistance, which is this factor, will be 0, and if the car is not pulling any other thing, the drawbar pull also will be 0. So we only need to consider the air resistance and rolling resistance only. So we can write the power in watts will be is equal to half CD rho A VQ, which is the power for air resistance. So the force of drag force equation is half CD rho A V square. So we know the power is equal to force into velocity. So for drag force into velocity will be is equal to this section, and this will be the roll resistance into velocity. So by substituting all the factors here, we will get a quadratic equation, and we can simply find the velocity v from here by solving this equation. So we will be able to find the top speed, and you must notice that the w plus df is in newton, the rho, which is density, is in kilogram per meter cube, a is in meter square, cd is a constant, power is in watts. So we will get v in meter per second. Velocity will be in meter per second. So we just need to convert it into kilometer per hour. So it is by into 10 raised to minus 3 into 3600. So we will get 18 kilometer per hour. But the truth is, this method won't give you the right answer always, because we can design an engine in two ways: by making it a higher revving engine, just like a Formula 1 car engine, which is able to generate a horsepower of nearly 700, but it is not that torquey. And we can also generate the 700 HP to make an engine that is suitable for a truck or a Taurus like this. So we have to consider the gear ratios, the size of the tire, the speed of the engine, power, everything to get the right top speed from a calculation. So we must look for another method for getting the correct answer. So let's look at the alternative we have to find it. By using this method, we will be able to find the top speed of the vehicle by considering the speed of the engine, maximum speed of the engine, or maximum speed the engine can have, which is in RPM, and it is also we have to consider the gear ratio too. So in this method, we will be able to predict the top speed of the vehicle with respect to the speed of the engine and the gear ratios we have. So it will be the maximum speed the vehicle or the car can take with the speed of the engine. Additionally, in this method, we need to find the top speed. So we also need the data about the radius of the tire of the car. So we can simply substitute it in this equation. So we can find the angular velocity because we know the rev of the engine in rpm. So we have to substitute n in rpm to find the omega, which is angular velocity, and multiply it with the radius of the tire, and we have the gear ratio. Gear ratio will be the product of uh, total gear ratio will be the product of gear ratio into axle ratio, or the ratio of the final drive of the vehicle. So by substituting this value, we will get V in kilometer per hour. So by cross multiplying, we will get the answer, which is the top speed or the velocity of the vehicle in kilometer per hour. So we doesn't need to give any reduction to the answer. But there will be another problem. If the car that we are considering is doesn't have that much better aerodynamics, or the drag coefficient of the car is very big. But the lack of aerodynamic efficiency of the car that we considering will reduce the top speed of the car that we found from the previous equation. So the most effective equation to find the top speed of any kind of vehicle is the one that I am going to show next. So look. That exact method, we will use all the data to find the tractive effect of the vehicle, and we will find the top speed from that tractive effect. So it will be the exact top speed of the vehicle that we are checking. And we know that in an internal combustion engine, we are getting the peak torque at a lower rpm, and the peak power will be at a higher rpm. So we have to find the torque at the higher rpm the engine actually revving. For that, we have to take the torque from the power equation. We will find engine torque at the maximum engine rpm. So we will get the engine torque in newton meter by substituting the power in watts here and speed in rpm. Next, we need to find the wheel torque. The wheel torque depends on the engine torque, the overall gear ratio, as well as the transmission efficiency. We have found the engine torque using this equation, and we know the axle ratio, which is the final drive ratio of the vehicle, and the gear ratio of the top gear. And we must also need to consider the transmission efficiency, which is usually taken at 90%. So we have to substitute 0.9 here. The value of TW will be Newton meter if we consider the TE in Newton meter. So next we need to find the tractive effect. So the tractive effect will directly depend on the radius of the tire, which is the final part that is transferring all the propelling force to the road or the surface the car is moving. So we can find the tractive effect, which is F, by dividing the wheel torque with the radius of the tire. So we will get the tractive effect in Newton. We know that the top speed of the car will be limited by the resistance that is faced by the vehicle when it is moving. When the resistance will get equal to the tractive effect, the vehicle can't accelerate anymore, and the speed of the vehicle will be limited in this point, and it will be the top speed of the vehicle. So we have already assumed that vehicle is moving in a straight road with no inclination, so the gradient resistance is 0, and we only have rolling resistance as well as air resistance. So we can say that the tractive effect will be equal to air resistance plus rolling resistance. So we can substitute it as half CD rho AV square, which is the air resistance drag force equation, plus the rolling resistance force equation, which is plus df. CD is coefficient of drag, rho is in air density, which is kilogram per meter cube, A is the frontal area in meter square, V is in meter per second, and this is also a constant, and W and df is in Newton. So we have already found a tractive effect, so we will get a quadratic equation by substituting all the values. So we can simply find V from here, which we will get in meter per second, and we can convert it into kilometer per hour to find in the top speed of the vehicle. If it doesn't got the value of the frontal area of the vehicle, the frontal area is the total area that is covered by the vehicle when we look it from the aft of the vehicle. So it is actually found from a parallel beam testing. If the vehicle is packed in a non-inclined plane, and we are impinging some parallel beams into it, and we will get a shadow behind, and the area of the shadow will be the exact value of A. So if it doesn't have that, we can assume that the 80 percentage of the uh, product of height and width of the vehicle will be the projected frontal area. So we can simply get the uh, height of the vehicle, which is this, and width of the vehicle, and we can simply find the product of it and find the 80% of that product. It will be considered as the projected frontal area. So the technique used by Jason in engineering explained is not always applicable to all the vehicles. It is only applicable to hypercars that is only designed to concentrate to provide a higher top speed. So if you learned about how to find the top speed of a vehicle, actually any vehicle, whether it is a sport utility vehicle, truck, or a hypercar, you can simply find the top speed by using these methods. If you like the video, give a thumbs up and don't forget to subscribe to my channel. Thank you for watching.